Another very useful drafting tool in AutoCAD is the ellipse command. Now we've got a new drawing for this particular video. It's called cylinder.dwg. You can download it from the library to follow along with this particular video. So what we're going to do, we're going to utilize the ellipse command to create an isometric view of a 3D cylinder. Now bear in mind, we're not 3D modeling. This is a 2D drawing and it's an isometric view of something 3D. So it's a 2D representation of a 3D object, if you get my meaning. So in the cylinder.dwg file, when you open it up and go to the model tab, you've got these two vertical lines on the objects layer. There's the objects layer. So make sure that you're on the objects layer so that anything you draw will go onto that layer. We're then going to pop over to the draw panel here on the home tab on the ribbon, and the ellipse command is here. Click on the little fly out next to it. You'll see that you've got various options available. You can draw ellipses using a center point. You can draw ellipses drawing an axis and an end point. You can draw an elliptical arc. Now I'd like you to use the axis end option. Click there like so. Come into the drawing area. So it's asking you for the axis end point of your ellipse. Notice on the command line you can also draw an elliptical arc, or you can go to the center option as well. So if I right click now, I can jump into arc or center. I don't want to, so I'll hit escape once to lose the shortcut menu, because I want to use the axis endpoint method, because I've got endpoints of these two vertical lines that I can use. So if I click on the left hand endpoint there, can you see? So it's on the left hand line, top endpoint. There's my first point of my ellipse. It's now asking for the other endpoint of the axis. So you're coming across to the corresponding endpoint here, left click to confirm. And now, as you move, can you see there's your ellipse? You're now specifying the vertical axis of the ellipse. And as you move the mouse up and down, can you see it looks like the ellipse is rotating around that horizontal axis? And you can actually rotate it around that horizontal axis. So if I now right click and select rotation, I can specify the rotation of the number of degrees around that horizontal axis. Type in 60, which is a standard isometric rotation angle. Press enter to confirm. And there is the first part of your representation of your 3D cylinder. So it now looks like the top of a cylinder. And it's the circular top of a circular cylinder, but imagine you've rotated it through 60 degrees to look at the top of it. That's exactly where you're coming from with ellipses. Ellipses are incredibly useful for this. We now need to create an elliptical arc. Now, the way to do this is very quick and easy. I can just jump back to the draw panel, click on the flyout and select elliptical arc. Come into the drawing area, and now it prompts me for an axis endpoint of an elliptical arc. So what I've got to do now is use the endpoints at the bottoms of the lines. Endpoint there, left click. Endpoint there, left click. So now this is going to specify an elliptical arc. So I'm going to right click again and select rotation, like so. Again type in 60 for that rotation around the horizontal axis and press enter. Now it wants the start angle. Now remember, you're drawing an arc, so it needs to go counterclockwise. So you need to go counterclockwise, not clockwise. So if I'm going counterclockwise, which way do I need to place my arc? Think about that for a moment. And if you want to go counterclockwise, you're going to have to go from left endpoint all the way through to the right endpoint. Clicking on each endpoint, and there's your elliptical arc. Roll back a notch on the wheel. You now have a nice isometric view of a 3D circular cylinder. So it is a 2D representation of something 3D. That's why ellipses are incredibly useful, and if you utilize that rotation option and either use 30 degrees or 60 degrees, that gives you the isometric view of something that could be a 3D object.